Hi all. We'll see the further topics which is continued by the last video. So next topic is process concept. In process concept, process abstraction, process states and transitions, process control blocks. These are all the three topics which is covered under the process concept. What is process abstraction? A process is an instance of a program in execution. It includes program code, data, resources, and execution context. Execution context in the sense program counter, CPU registers. Example. Process states and transitions. Processes transition between states, which is new, ready, running, waiting, or terminator, which have already seen about all the states briefly. So here we move the further topic. So based on events such as CPU scheduling and input output operations and user interactions. Process control blocks. PCBs store process informations including process IDs, state, priority, scheduling information, memory allocation, and input output status. These are all the process control blocks which has happened. So next, process scheduling. In process scheduling algorithms are used for making process scheduling. Process scheduling algorithms determine the order in which processes access the CPU. Common algorithms include first come, first served, shortest job, next, round robin, priority scheduling, multi level queue scheduling. These are all the process scheduling algorithm which is used to allocate the CPU for each and every process by different method. Scheduling criteria. Schedulers prioritize processes based on criteria such as CPU burst time, process priorities, deadlines, and fairness. This is the scheduling criteria. Dispatcher. Dispatcher is responsible for context switching, transferring control between processes, and managing CPU state during process switches. And this is the diagram for scheduler and process states. In this, once we create a new process, it is created and moved to the ready state. There should be a three types of scheduler. We must know about the scheduler. There should be three. First, long term, short term, and middle term. Long term in the sense it's completely a new process. So it will take a long time to execute the process. It's short term in the sense once we executing the process there should be some need of resources which is not allocated to that particular process, so it turned to the waiting state. Once it got the resources, it's again moved to the running state. This short time scheduling is a short term scheduler. Middle term scheduling is once we execute the process, the other process requests the same in the sense that process might be in the hold state. So at that time, previous process once complete the execution, then the waiting process may resume to executing the particular CPU executing by the CPU. That is called middle term scheduler. So in this case, the long term scheduler which is mentioned in the very beginning state of the new state, and short term in the sense once the process is in ready state, it's scheduled, dispatch, and priority time quantum based on all those things. It should be in the running state. Once it's stopped for allocating the any other extra resources, at that time the short term scheduler must await to reschedule that, and it moved to the running state, and once it completed it returned to the exit state. It's also the middle term in the sense based on the IO request or waiting or block the other process, Once the process timed out, the block is suspended, and the suspended process is ready to execute the executed for the operations. So thank you.